Our last transformation that we have to cover before we tie it all together is D. So D is not in the bracket with X, so it's a transformation on Y. So it's a Y transformation because it is not in the bracket with the X. What does it make it do? Well, anything with Y is as it should be. So if it looks like a plus D, you go up. So if I have f of x is equal to 3x squared as my base graph, if I put a 2 on the end of it, it's going to go up. If it's minus d, it's going to go down. So if I have y equals f of x, or 3x squared again, and I put a minus 3 on the end of it, or if I go f of x minus 3, it's going to move the whole graph down. Okay. So let's look at what it's going to do. Here we go. We have a 0.24 on my base graph. What is the corresponding point going to be, and how would the graph of the function be obtained from the base graph? Well, this is a transformation on y, as it should be. So I'm going to go down 7. In other words, I'm going to subtract 7 from my y value. So I'm going to take away 7, and I end up with the 0.2, negative 3. You could pause the video and do the next two if you want to, or you can do it with me. So we have a 0.24. This is a plus 2, so it's going to move my graph up 2. In other words, it's going to add 2 onto my y values, as it should be. Y's are simple. My new point would be 2, 6. All right, last one. You have to know what your base graph is. My base graph is y equals x squared. This is a transformation on y because it's not in the bracket with x. It's going to make it go down 5. And so I'm going to take my y values and I'm going to subtract 5. So if I have a 0.24 on my original graph, I'm going to minus 5 and I get a 0.2, negative 1. Something I didn't mention is I tried really hard to pick points that were actually on the base graph. So like 2, 4 is a point on y equals x squared. And so if I wanted to double check I did this right, if I plug in 2 for x, I get 4 for y. If I plug in 2 for x, 2 squared is 4, minus 5 is negative 1. So if you're given the equation of a graph, you're always allowed, and maybe I'll remember to do that on this graph down here, you can check points. You can be like, hey, I did all these transformations, but are they right? And so you can plug in values of x and solve for y and make sure that your point is correct. All right, let's look at this transformation in action. This one is going to cause my graph to go up 2. In other words, my y values are going to add 2 onto each of them. You can transform specific points. You could pull out these 1, 2, 3, 4, 5 key points. And then you can add. So if I have a point like negative 5, 2, I can add 2 onto the y value to see that it goes to negative 5, 4, or I can simply go, hey, I'm going to go up 2. 1, 2. I'm going to take this point, go up 2. Connect them as I go. I'm going to take this point, go up 1, 2. I'm going to take this point, go up 1, 2. Maybe I need some others just to keep my line straight. There we go. And then lastly, this guy, 1, 2, and then I do my nice little curve. So you could keep transforming points, or you can do it like this one. So now this one I've left you. I'm like, hey, can you draw the base graph, and then can you draw the transformation? So these ones, they're going to ask you, can you draw y equals x squared first? Do you remember what the table of values would look like? So y equals x squared starts at 0, 0. You put in x is 1, you get y is 1. You put in x is 2, you get y is 4. You put in x is 3, you get y is 9. Then you can mirror image that because it's your base quadratic function. Connect the dots and connect the dots. Okay. Now the transformation is that they want my graph to go down 3. In other words, my y values are going to subtract 3. So I'm going to take all these points and just move them down 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and lastly 1, 2, 3, and 1, 2, 3. And then I just connect the dots. Now some of you might be saying, hey, I just knew that the vertex was 0, negative 3. And then I did the normal shape, and that's great. That's why I don't really like that this textbook focuses so much on base graphs, because you can always just do like a table of values or whatever to get them. But so the whole point of 2.5 is to practice this idea of transforming. So the idea of moving it up, moving it down, moving it left, moving it right, and so on and so forth. Okay, go and practice D, and then we'll move on to the last couple videos.